Hi students. In the last lecture we have seen the classification of monitors. So monitors are basically classified into CRT based display devices and non-CRT based display devices. So CRT based display devices means the monitors which contains the cathode ray tube, and the monitors which doesn't contain cathode ray tube is called non-CRT based display devices. The example of CRT based display devices are direct view storage tube, random scan display device, random scan display device, and the examples of non-CRT based display devices are LEDs, LCDs, plasma, etc. etc. So today we'll focus on the CRT based display devices. Now these CRT based display devices are again categorized into two categories. So if you see the classification of CRT based display devices, then they are categorized into two categories, and these two categories are line based system and point based system. So CRT based display devices are categorized into line based system and point based system. Now what is this line based system and point based systems are? So line based systems are those systems in which any entity on a screen is made up of small lines, and in point based system any entity on a screen is made up of points. So that is the difference between a line based system and point based system. For example, in line based system even a circle is made up of small lines, or any curve is made up of small lines. Now if you see, a circle is made up of these small lines. So or curve is made up of small lines. So if the figure is made up of small lines, then it is called a line based system. And in point based system, any entity on a monitor is made up of points. For example, a circle in point based system would look something like this. So this is circle in point based system, and this is circle in line based system. In line based system, any circle or any curve is made up of small lines, and in point based system any circle or curve is combination of points, is made up of points. Now this point based system is mother of all the new advanced display systems or display devices. Okay, all the modern display devices are point based system. So how, I will explain it later. Now first we'll see a line based system. The example of line based systems are examples of line based systems are direct view storage tube and random scan display device. Whereas the examples of point based system is raster scan display device. Okay, so the three CRT based display devices are categorized into two categories, line based system and point based system. Examples of line based systems are DVST and random scan, and examples of point based system is raster scan display device. Okay, so hope you understand this line based system and point based system. Now we move on to the first display device, that is DVST. So we will see the DVST in a bit more detail. So DVST, that is direct view storage view. Okay, this is also called as DVST, direct view. So there is a direct image generation on a screen. There is no buffer or there is no memory in this DVST. Now we have seen the working of CRT. We have seen working of a CRT. So in the CRT there is a phosphor coating from inside the screen. This is a phosphor coating. This is phosphor coating. Now this phosphor coating are of two types. There are two types of phosphor coating. So we'll see those two types first. Phosphor coating are of two types. One is a long persistent phosphor coating and another one is a short persistent phosphor coating. Long persistent phosphor coating and another one is short persistent phosphor. So long persistent phosphor coating and short persistent phosphor coating. Now what is the difference between long persistent and short persistent phosphor coating? So in long persistent phosphor coating, when an electron beam from the electron gun hits the screen or hits the phosphor coating from inside. So if this screen is coated with long persistent phosphor coating, then the bright spot, if you see a monitor here, if this is a monitor, then there is bright spot which appears due to striking of this electron beam would remain there for 1 to 2 hours. Okay, so if the screen is coated with long persistent phosphor coating, then when the electron beam strikes the phosphor coating, then the bright spot which appears on a screen would remain there for 1 to 2 hours. So that is why it is called long persistent phosphor coating. Whereas in short persistent phosphor coating, when the electron beam strikes the phosphor coating, then the bright spot would appear for some milliseconds, and once it eliminates for some milliseconds, it diminishes. So the life of this point depends upon the type of coating provided inside a screen. If it is a long persistent phosphor coating, then that bright spot would remain there for 1 to 2 hours, and if it is coated with a short persistent phosphor coating, then this bright spot would remain only for some milliseconds, and after that it diminishes. Okay, so this is a difference between a long persistent and short persistent phosphor coating. Now coming back to the DVST. Now in DVST, this phosphor coating is a long persistent phosphor coating. So it is a long persistent phosphor coating. Okay, so when this electron beam draws a certain entity on a screen, then that entity would remain there for 1 to 2 hours. Okay, you cannot erase it. Normally when you use any CAD software, you draw a line, then you find it incorrect, then you immediately erase it and draw a new line, correct line. But if you are using a DVST, then if you draw an incorrect line, then it would take 1 to 2 hours for DVST to get it diminishes, and then only you can draw a new line on DVST monitor. Okay, that is a drawback of this display device. Okay, so if you draw a line, then this line would remain there for 1 to 2 hours, and if you want to erase this line, then this screen has to be then this screen has to be flooded with certain amount of voltage to erase the entity. Okay, so erasing is very difficult in DVST. Okay, so erasing is very difficult in DVST, and DVST is a flicker-free device. Flickering is a phenomenon. If you capture your TV screen using a mobile, and then you play that video in a slow motion, then you can see that the TV screen appears and diminishes continuously. Okay, you cannot see a continuous picture on your TV monitor, but the picture is coming and going. So that is flickering. Okay, every advanced monitors or nowadays monitors, they have a flickering activity or flickering phenomena in the monitors. But this DVST is a flicker-free device. Here, this electron beam is act as a pen. Wherever you want a line or a circle or a curve, then this electron beam would act as a pen, and it will draw the entities on the screen. So this DVST is a flicker-free device, but erasing an entity on a screen is very difficult. Similarly, animations also very difficult in this DVST. Okay, so DVST is direct view storage tube. It has got long persistent phosphor coating. Once an entity is drawn, then it becomes difficult to erase. To erase an entity, we have to flood the screen with certain voltage, or the entity would remain there for 1 to 2 hours, and then only it will diminishes automatically, and then it is a flicker-free device. This is a very old display device in the evolution of monitors. Now we move on to the second line-based display device, that is random scan display device. Random scan display device. This is a second CRT based monitor display device, and it is as we discussed, it is a line based system. That means any entity on a monitor is made up of small lines. Now the difficulty in DVST is tried to remove in this random scan display device. The difficulty in the DVST is erasing an entity is difficult. Erasing an entity is difficult because the screen is coated with long persistent phosphor coating. Okay, so in random scan, the phosphor coating provided inside the screen is short persistent phosphor coating. That means when the electron beam strikes the phosphor coating, then a bright spot would appear on a screen, but it eliminates only for some milliseconds, and after that it diminishes. So if you see an architecture of random scan display device, so it is something like this. This is a buffer provided, buffer or a memory. Then a controller, is provided, and this is a screen. Remember, random scan display device is coated with short persistent phosphor coating. That means if you draw these 4 lines, this particular entity is made up of 4 lines. Say this is L1, this line is L1, this line is L2, this line is L3, and this line is L4. So I have made one entity which is made up of 4 lines. Okay, and the coordinates or the positions of L1, L2, L3 and L4 are stored in the memory. So the information regarding this 4 line is stored in memory. L1, L2, L3, L4. Information means L1 starts from which point or which coordinate and it ends at which coordinate. L2 start point is which coordinate and end point is which coordinate. Similarly L3 and L4. So the information of L1, L2, L3 and L4, they are stored in this memory or a buffer, and the information is constantly transferred to the screen by using this controller. The function of controller is to transfer the information from the buffer to screen, and this would take around 60 cycles in a second. That means 60 times the information of L1, L2, L3 and L4 is transferred to a screen 60 times in a second. Okay, that means the transfer frequency of this controller to send the information from a memory to a screen is 60 Hertz, 50 to 60 Hertz, 50 to 60 Hertz. Okay. And this L1, L2, L3 and L4, they appears and diminish about 50 to 60 times in a second, because once the information is transferred to a screen, then these 4 lines would eliminate and remain for some milliseconds, and after that diminishes. Again the controller transfers the information, again this L1, L2, L3, L4 will eliminate and then diminishes. So the function of controller is to transfer the information 50 to 60 times in a second, so that this entity would look continuous appearance on a screen. So because of this 50 to 60 times transfer of the information, the human eye or naked eye can see the entity is continuously appearing on a screen, but it is in actual the entities are not appearing continuously. They are eliminating, diminishing 50 to 60 times in a second, but the naked human eye cannot detect this flickering. So this is the flickering. So naked human eye cannot detect the flickering which is happening in the display device. Okay, so this is a random scan display device. So in random scan display device, they are trying to eliminate some of the problems with the DVST, that is the problem of erasing by introducing the buffer and a controller. Okay. So buffer stores the information of the entities of a screen, and the function of a controller is to transfer the information to a screen so that the entity would look continuously appearing on a screen. So this is random scan and raster scan. Both are line based system. Okay, in next video we will be seeing the point based system, that is a random scan display device. So hope you understand DVST and random scan display device.